All right, hello everyone. Welcome to Unit 4, Lesson 1, Part 1, Ionic Bonding. After this lesson, you will be able to predict how an ion is going to form based on where it's located on the periodic table, create ionic compounds when you're given a cation and an anion, which we'll talk about later, and define vocab terms related to ionic bonding. Before you start this lesson, you need to be able to do the following things. You need to be able to tell me how many valence electrons an element will have based on where it's located on the periodic table. You need to be able to draw Lewis dot structures, understand Bohr models of the atom, and define the vocab words that are listed here. All right, so in our last unit, we talked a little bit about some of the words that were on the screen previously. And I want to focus on the words reactive and inert today. So we said inert meant it's not going to react, but what does it really mean when an element is reactive? Well, we are going to watch a classic chemistry video that will kind of illustrate that for you.
Straight out.
Straight out?
I just probably throw it that way, huh?
Yeah, throw it that way.
Good frisbee.
Ready?
All right, ready?
Everybody ready?
3, 2, 1.
Oh,
That's a little.
Oh!
Shh.
Oh! Oh!
Okay, so that video was a pound of sodium metal interacting with water. So you can see it is very reactive. So maybe you're thinking right now, sodium, like salt? So then why don't we explode when we eat salty food or salt snowy roads? And that all comes down to ion formation. So in that video, we saw sodium metal interacting with water. And the reason that it's so reactive is because of this tiny little electron right here. That one valence electron is going to make sodium metal really unstable, really reactive, and we kind of call it SAD in the chemistry world. When it reacts with water, what's actually happening is that it's losing that one electron to look like this. So now we've got the protons and neutrons in the nucleus, and our inner energy levels are exactly the same as before. But this outer ring is empty. That one valence electron was lost. And this is the sodium that you will see in table salt. This is the sodium that we use to salt roads. This is why you don't explode when you eat sodium. And we are going to classify this tendency that different elements have to want to be stable or happy by calling it the duet or octet rule. So most elements are going to follow the octet rule. And if you're familiar with root words, you might know that oct means 8. And that means that elements really, really, really want to have 8 electrons in their outermost energy level. So right here, the outermost energy level for sodium metal, it only has 1 electron, and it really, really wants to be full. But it's a lot harder to gain 8 electrons, or 7 electrons to get to 8, than it is to just lose that 1 electron. And so when it loses that electron, look what happens. Technically, this second level is the outermost energy level, and there's 8 electrons here. The duet rule applies only to hydrogen and helium because they only have this first energy level filled out. And remember, that first energy level is so small that it can only hold 2 electrons, and that's why it follows the duet rule. Some of you might have noticed this little plus sign that I added when we lost the electron to turn it into the sodium ion. So let's talk about what's going on with this plus sign in the next few slides. As we begin to talk about that, I want you to think back when we learned about subatomic particles, and we are going to compare those particles to money here to help us understand some of these positive and negative signs. So for the next few particles, I want you to remember that protons are positively charged particles. And I want you to imagine that every proton you see is like getting a paycheck. And electrons are negatively charged particles. So I want you to imagine that those are like paying a bill. So if I have the same number of protons and electrons in an atom, I'm going to have an overall charge of 0. This would be like earning $300 at work and then having to pay $300 in bills. You would have $0 at the end. And this is what most of your elements have looked like when you calculate protons, neutrons, and electrons. But what happens, like in the sodium ion, when I take away one electron? I'm going to have an overall charge of positive 1. And this would be like earning $300 in bills, earning $300 at work, and then having to pay to only $200 in bills. You're going to be left with $100. So if you take away or subtract something negative, you end up with something more positive. So let's look at the actual math for this. In our last unit, you should have figured out how to calculate numbers of protons, neutrons, and electrons just based on the little boxes on the periodic table. And if you can't do that, ask a teacher for help because you really need to know how to do this for the rest of the lesson. When sodium metal loses one electron, the electron count goes down by 1. So instead of 11 electrons, we've got 10 here. Now, to figure out the overall charge, we're going to take our protons, which are all positively charged. So that means this 11 is positive. And we're going to subtract our electrons. Because remember, electrons are like bills, protons are like paychecks. So if we have 11 minus 10, we're going to have a positive 1 overall charge. So are all elements going to lose electrons to be happy? Well, let's find out. Let's take a look at chlorine. Chlorine has 17 protons, 18 neutrons, and 17 electrons. I didn't draw the Bohr model for chlorine because it has quite a lot of particles and it's so much faster just to draw the Lewis structure. If you're confused about how to get this from this, call a teacher over and ask for help because, again, you need to be able to draw Lewis structures for this lesson. So, chlorine has 7 valence electrons. To get to 8, it's really a lot easier for it to just add 1 electron here. If it was going to lose electrons, it would have to lose 1, 2, 3, 4, 5, 6, 7 electrons in order to get to a full shell. So our rule here is that elements with 4, 5, 6, or 7 valence electrons can gain electrons to get to a full energy level. So you can see here, chlorine will gain 1 electron. Our electron count goes up by 1 to 18. And to figure out our overall charge, we're going to take our 17 positive protons minus our 18 electrons. So if you plug this into your calculator, you're going to end up with -1, which will be our overall charge. So we're going to talk very quickly about some vocabulary terms. When an atom loses electrons, it becomes positively charged, and we are going to call it a cation. When an atom gains electrons, it becomes negatively charged, and we call it an anion. The reason that I've got little drawings of a cat and an onion is that to help you remember these terms, the kind of classic chemistry mnemonic device is that a cation is positively charged because cats have paws. You get it? Like Paws, and paws sounds like positively charged. And on the other side, anion kind of sounds like onion. And I don't know about you, but when I chop an onion, I actually have to wear like lab goggles because it makes me cry so much. So when you chop an onion, it makes you cry, which makes you sad, which is negative. So if that helps you remember these vocabulary terms, use that device. If not, just remember cations are positively charged, anions are negatively charged. All right, remember valence electrons. You should be very familiar with this from last unit, but we're going to do a really quick review. And remember, this is going to be the easiest thing that you do all year in chemistry. All you have to do to figure out valence electrons based on the periodic table is look at what column it's in. So if the element is in this first column, it's going to have 1 valence electron. If it's in the second column, it'll have 2. We're going to skip this whole purple block and go over here. If it's in the third column, it'll have 3. Fourth column will have 4. Fifth column will have 5, and so on. So if I asked you arsenic, how many valence electrons arsenic had, you should tell me 5. We are going to just focus on these top rows, and we're going to zoom in really closely. Now, if you know the valence count, you also are going to be able to really quickly figure out how many electrons that element will gain or lose to form an ion. So let's take a look. We really looked pretty hard at sodium, and we saw that it had 1 valence electron, and when it lost that valence electron, it became positively charged with 1 positive charge. Now, if we have something with 2 valence electrons, like beryllium or magnesium, it's going to lose both of those 2 valence electrons, and it's going to end up with an overall charge of 2. Aluminum and boron are in the third column, so they have 3 valence electrons, and that means they're going to lose all 3 of those and end up with a positive charge of 3. Carbon and silicon, they are right in the middle, so they kind of have a choice. Do they want to gain 4 electrons to get to 8, or do they want to lose 4 electrons to get to 8? And because of this, because it's kind of the same for it to gain or lose, they are very rarely going to make ionic bonds. They are going to make covalent bonds, which we're going to talk about a lot more in lesson 2. Nitrogen and phosphorus, they're in the 5th column, so they have 5 valence electrons. Now, to get to 8, to satisfy the octet rule, they could either lose 5 or gain 3. And it's easier to gain 3, and that's what nitrogen and phosphorus are going to do. So when they gain 3 electrons, they are gaining 3 things that are negatively charged, and so the overall charge will be -3. Oxygen and sulfur are in the 6th column, so they have 6 valence electrons. To get to 8, they need to gain 2 electrons. When they do that, they'll have an overall charge of -2. And our last column here has 7 valence electrons because it's in the 7th column, and it just has to gain 1 electron, which was like our example of chlorine. And when it gains that 1 electron, it's going to have a negative charge of 1. our noble gases, you might remember from the previous unit, we said these guys were inert. And that's because they already have 8 electrons in their valence shell. So they don't want to gain or lose any of their electrons. They are happy. So they are not going to react. And if we tie this back to our vocabulary terms, these elements that are going to lose electrons to form an ion are going to be cations because they're all positively charged. These elements that will gain electrons are going to be anions because they have a negative charge. All right, here is where you are going to get some practice. You are going to figure out how many valence electrons each of these elements has, whether it gains or loses electrons to form their ion, what the overall charge is, and whether it's a cation or an anion. So take a minute and fill this out, get a stamp, and you're going to need this table for part 2. So make sure that you understand how to do this. All right, here are the answers. You can check them against your work and make any corrections you need to so you have the right information for the next video.